All right, so this next chapter that we're doing is all about linear motion or motion in one dimension. And we're actually skipping a chapter in the textbook. We're going to chapter 3 is what this is. So if you're looking in the textbook for information on linear motion, look for chapter 3. Okay, so these are the objectives for this chapter. Specifically, today we're going to focus on these first three, talking about frames of reference, displacement, what's the difference between displacement and distance, velocity, how to calculate it, and then also how to construct and interpret position time graphs. Okay, so first of all, frame of reference. This is very important to specify a frame of reference in any problem that we do from here on out. A frame of reference is just a method of specifying location. Any frame of reference is technically valid, but it's usually best to choose one that is convenient and simple. So for example, if I were to ask you how to get to your house, most people would start off by saying, okay, well, from here you are going to take a right onto Midway, and then you'll take a right onto whatever, Hebron. But we don't even need to go that far, because if you notice, the first thing I said was, from here, you do this. That was specifying a frame of reference, even if I didn't necessarily mean to do so. I'm telling the people where I'm starting, or where the origin is. And when I would do something like this for people coming from out of town, I wouldn't give them a frame of reference starting from the school, because they don't know where the school is. I would say, okay, well, as you come in from Oklahoma on High 35, you're going to do this. You use a frame of reference that is easy and simple for the people that you are trying to tell the location to. A number line, like you see down here, is also an easy frame of reference. We're specifying where the origin is. And this is where we're going to be doing a lot in the problems that we do in this chapter, is we're going to say, okay, the origin, or 0, is right here. We're going to define the origin as at the ceiling or at the floor. And all of our motion is going to become either positive or negative based on that frame of reference. So it's very important to specify where your origin or where your 0 is going to be in every problem that you do. Okay, so one of the first vocabulary words that you're going to learn in this chapter is displacement. Displacement is the distance and the direction from initial to final position. So you do need to write these two equations down. This top one is specifically for horizontal motion. And so that's why it's labeled as an X. X is horizontal. Y is then for vertical motion. Notice that they're exactly the same equations. It's just the which one is which for horizontal versus for vertical. In these, the different symbols that we have here, this triangle is technically a Greek delta symbol, and it means change in. So the displacement is technically the change in X or the change in Y. So it's, how does my position change from my initial position to my final position. It also has a direction that's going to be associated with that, and we'll talk about some directional words that we'll use in on the next slide. This F right here, subscript, means final, and the I subscript means initial. So it's very specific where you put the final position and the initial position in this case. Displacement is usually measured in meters, but it could be in something else like centimeters or in kilometers, but it does need to be a unit of length. Okay, so these are the some directional words that we can use to denote whether it's a positive or negative displacement. Some positive words would be forward, right, up, north, or east. Negative words then would be backward, left, down, south, or west. And so these will help us to determine whether or not we have a positive or a negative displacement after we calculate it using the equation on the previous slide. Okay, so the difference between displacement and distance, displacement has that direction associated with it. Distance is going to be just a number. So the best way to do these type of problems, these ones you notice, you can see east and west as our directional words. I'm just going to draw a number line. And so I'm going to say here is my origin, here's 0. Anything to the right is east, and anything to the left is going to be west. So I start at 0, and I go 200 meters east. Okay, so I go 200 meters east, and then I go 300 more meters east. So 300 meters east. So what's the total distance that I've traveled? Well, I've gone a total of 500 meters. For distance, you don't need a directional word. So it doesn't matter which direction I went for the distance. It just matters that I went a total of 500 meters. The displacement, though, does have a direction. So what's my final position? Well, my final position is way over here at 500 meters. And that's the east direction. My initial position was 0, so if I subtract those, 500 minus 0, I get 500 meters. And then I have to include a directional word, so I say east, or put an E to symbolize east. Okay, so now if I go to my next one, erase what I just did. This time I go 200 meters east, so 100, 200. And then I go 300 meters west. So I go 1, 2, 3. So this is my final position right over here. I'll mark it in red. This is my final position. My initial position was, I'll mark it in blue. So I want to know, how far did I travel? What is the distance that I went? Well, I went 200 meters east and then 300 meters west. So that's a total of 500 meters traveled. My displacement, though, is the difference between my final and initial position. Well, here is my final position, right here at this red. That's 100 meters west of where I started. So my displacement is actually 100 meters, and my direction would be west. It doesn't matter that I went east first and then back west. I ended up 100 meters west of where I started. Okay, so let's erase that and do the third one. Okay, so I am starting at 0. I'm going to go 200 meters east, so 1, 2, and then I go 200 meters west, 1, 2. So if I mark again, my final position is right there. My initial position was, same spot. So what is the total distance that I traveled? Well, I went 200 meters east, then 200 meters west, so that's 400 total. My displacement, though, I'm actually in the same position that I started in. That means that my displacement is 0 meters. Because it's displacement, I still need a direction, so I either need to say east or west. It doesn't really matter in this case because I went both ways. I just ended up at the same spot, so I can say 0 meters west. Okay, along with the difference between displacement and distance is the difference between velocity and speed. Speed is specifically based on distance, meaning that it does not have a direction to it. It is just a number that also has a unit associated with it. When we are talking about velocity, though, which is what we'll talk a lot about in the next couple chapters, we're basing that on displacement. So it does need a direction associated with it. If I say that I'm traveling 35 miles per hour, but I don't tell you which direction that is or whether it's a positive or negative velocity, then I'm specifically talking about speed and not velocity. If I say I'm going 35 miles per hour west, then that would be a velocity because I have now included a direction. Okay, you need to write down this equation for average velocity. Velocity is based on displacement, so we are going to calculate it based on the displacement divided by the time interval. So remember, displacement is this value right here, this change in x, it means displacement. My change in time is going to be over what time period am I doing that displacement. Notice again that we have subscripts on our positions, so this F and this I, and then also I have subscripts on my times. Again, the F means final and the I means initial. This right here, V av, if you notice that, this av, AVG. AVG means average. We need to be very specific about our subscripts in these next couple chapters, because there's going to be several V's in an equation or several T's in an equation, and we want to make sure that we know which V we're talking about. Is the average velocity? Is it the initial velocity? The final velocity? And so that's why you're going to start seeing a lot of subscripts in all the equations we use. Velocity can be a positive value or it can be a negative value, so keep that in mind. Depending on whether the displacement was positive or negative is going to determine whether your velocity is also positive or negative. Okay, so if we do a couple of examples, and we'll again do it on a little number line with this calculating average speed versus velocity. So let's say we start here at 0. A car travels east 200 kilometers. So it goes 200 kilometers east, and then to the west 300 kilometers. So 1, 2, 3. So my ending spot is right here where the red is. My initial spot was where the blue is. So I want to know, or the entire trip lasts for 4 hours. That's my time period. So what was the car's average speed? Well, speed is based on distance per period of time. So the total distance that I traveled was 200 east and then 300 west, which is 500 total. So 500 kilometers total. And that was over a period of 4 hours. So if I go ahead and divide those, 500 divided by 4. Okay, so you get 125 kilometers per hour. Okay, so that would be my average speed, 125 kilometers per hour. So what was the car's average velocity? Well, velocity, remember, is based on displacement, not on distance. So if I look, my displacement is the distance and direction from my initial to final position, which is actually only 100 kilometers, and that is towards the west. Okay, and the duration of the trip was 4 hours. So 100 divided by 4 is 25. So my average velocity is really 25 kilometers per hour, and I have to provide a direction with that, which will be to the west, because that's where I ended up. All right, so position time graphs. A position time graph has time on the x-axis, so down here, and it has position on the y-axis. Time is normally measured in seconds, and position is normally measured in meters. So if we were to look at the slope of this line, or to calculate the slope of this line, besides just looking and saying, okay, we do rise over run, so we get 100 rise over a 100 run, and the slope would be 1. Specifically, I want to know what are the units of the slope. So if I do rise over run, my rise units are meters, my run units are seconds. So my slope has the units of meters per second. Well, what is that a unit of that we just talked about? Velocity. And this is something that is going to come in very handy for us as we're looking at these position time graphs. When we find the slope of a position time graph, we are actually finding the velocity with which this object or person was traveling with.